Okay, we are on, we are rolling. So this is all I want you to do. I want you to be able to find the slope very easily. Okay? Now, 99.99% of all graphs are going to look like this. Okay? This whole thing is called a graph. Okay? Some people call it a chart. I think Excel calls it a chart. I've never called it that. I call this a graph. Yes? I call this a plot. So this is a plot. This whole thing is a graph. You got that? Understood? Now, what fancy math science people call this is a curve. A curve can be a straight line. What's the angle of the curve? 180 degrees. Understood? So a curve, they say a curve, but they could be a straight line, a curve, okay? So when it says on your paper, find the area under the curve can be a straight line. Understood? Are you sure? Okay. So let's just do this. I'm only going to do, I'm so confident, Alyssa, that you're going to get this. I'm only going to do one example to find slope. Are you ready? Now, you can only do this simple shortcut method if the plot goes through the origin. Okay? Clear? Yes? Okay. You also want to use an equation which you can easily memorize within the next 25 seconds. M equals y over x. In this case, y is distance in meters and x is time in seconds. Okay? Clear? Yes? Okay, good. I want to erase this. I just saw this as a mistake. Okay? Are you okay with that? You sure? We are okay. Okay? We are okay. Are you ready? Now, you've got to be specifically and absolutely 150% completely top to bottom, up, down, left, right, black, white, absolutely honest with me. I'm going to ask you a question. Is that correct, Alyssa? Are you sure? You want to look right here, and I'm going to ask you a yes or no question. And if you don't understand it, what would you say? No. If you do understand it, what would you say? Yes. It's not yes, I don't really understand it, but I'm tired of you talking to me. It's late on a Thursday, get out of my face. I mean, yes, I understand it, I'm cool, and you're not. Okay? Understand? Okay, good. Are you ready? Okay. This is 20 on the x-axis, and this is 100 on the y-axis. Question number one. Are you ready? This point is going to be represented by the ordered pair 20, 100. Yes or no?
Yes.
Excellent. I like that. Excellent. That was a very confident head shake, Alyssa. It was confident. The rapidity of that was like, yeah, it's cool. I get this. Yeah, I'm there. Okay? Either that or you were having a small seizure, which is, I'm glad you weren't, because you're still smiling. You could be smiling and having a small seizure, I suppose, right? So, now, you ready, Alyssa? Question number 2. Did I say I was asking you one question?
You said you were there, yeah, I think.
I'm live. Well, I'm going to ask more than one question. Okay, question number 2. That ordered pair, y is 100 and x is 20. Do you understand that, yes or no?
Yes.
Yes, good. Question number 3. M is represented by slope, yes or no?
Yes.
Yes. Y equals, M, the slope, equals y divided by x. Yes or no? Yes or no? Yes. Okay. I would always give that to you. You don't even have to memorize it, but you might want to. Okay, good. Excellent. Good. Question number 4. Y is 100, X is 20. Yes or no?
Yes.
Excellent. Therefore, 100 divided by 20 equals 5. Yes or no?
Yes.
Okay. Therefore, the slope of that line is 5. Do you understand that, yes or no, Alyssa? Excellent. Last question. Okay? This is the hardest one. Are you ready? You look nervous. Are you nervous? A lot of confidence there. There's a lot of confidence in a head shake. You say, no, I'm not nervous. No, we're cool. Okay. If I took the following point and I said X and Y, okay? And I said that if I said that the X value is 5. I said to you, now this may not look proportional, but if I said to you, in that point, the X value is 5, okay? The X value is 5. You ready? Are you sure?
Yes.
You're ready?
Yes.
This is going to be hard. Can you do this? All right, no one else can answer this. This is Alyssa. Okay? 5 points extra credit if you answer this question within 10 seconds, okay? Can you do this? You willing? Okay. I want to know if the slope of this line is 5, yes? And that's because this point is 20 and 100. So the slope of this line is 5. And I said to you, here's a point here with X and Y, and X is 5. Right? You sure? Okay. What is Y? Don't tell her. Let her do it. Clock goes on now.
100.
Well, let's test that. Let's see. You have the chance to redeem yourself. Okay, you ready? So you're saying that Y is 100, right? So 100 divided by 5 is what? 20, right? So could Y be 100? Because doesn't it have to be 5? All right, so okay, give it one more shot. Chance to redeem yourself. What would Y have to be if the slope is going to be 5? What did you say?
1.
No. It's Y over X, not X over Y. That's good. I understand that guess. That was actually a pretty good guess. Y over X, right? All right, go ahead. Give it one more shot. You can do this. Okay. Well, let's see. Doesn't Y over X have to equal what? Y over X has to equal what? The slope, right? So what's the slope? What's the slope? Isn't the slope 5? So doesn't Y divided by X have to equal 5? Right? So what divided by, so Y over X equals 5, right? Right? Yeah? Well, if this is 5, now, this is 7th grade math. It can be 7th grade math. Let me ask you the question. You ready? What number divided by 5 equals 5? 25, right? Isn't that what you said? Yeah, that's it. So this Y would have to be 25, right? Right? Because what's the slope of this line all across this line? 5. Yes?
To me, it's actually possible in a logical way because if that point, if the origin is 0 and it's increasing as it goes right, then it doesn't make sense if 25 is on the left side of 20. Is on the left side of 20. If 25 is what?
25 is here,
Oh.
5 is here.
I got it confused. Sorry.
Now, I said it's not scaled, right? It's not perfect, right? So was that easy? Now, don't you think the higher you get, maybe it's steeper, right? Right, but it's not steeper, is it? Isn't it the same slope? How do people feel when you're climbing a mountain and you're really high? It seems like it's steeper, right? But this is important. The slope's the same on the entire line. You get that? Shall we do one more? Yeah? Okay. All right, let's do one more. Okay, let's do one more quickie. Okay? And all you have to do, we're not going to get really complicated now. We're just going to try to get the slope, and that's it. Okay? That's it. That's all we're going to do. All right? Okay. We'll take a point here. We'll say that point is 16. We'll say that point is 64. Okay? All right? This is 0 on the y, 0 on the x, 0 on the y, the origin. What's the slope? Laura? 4. Because it's 16 and 64, right? 64 over 16 equals 4. Y over x equals 4. Y over x equals m. Yes?
Yeah.
Right?
Yeah.
Let me ask you again. Can you find an ordered pair on a plot? Of course you can, right? Can you? Yeah. Can you identify the y and the x? Which is y, which is x? Which is x, which is y? Can you say y divided by x?
Yeah.
That's it. There's no more than that. That's it. We're done. Okay? Now, are you all right with that? That's slope. When it goes through the origin, it's that easy. Okay? You're sure? Okay. Now, let's do this. Now we're going to do something a little harder, but it's still the same. Okay? Now, velocity time. Not distance time, velocity time. Okay? Not distance time, velocity time. Okay? Now, you see I have a line, a horizontal line, then down, right? Okay, yes? Yes? All right, yes? Okay. Let's examine this for a moment, okay? Let's examine this. All right. Velocity time, okay. If I'm on a velocity time graph going like this, am I increasing velocity, decreasing velocity, or do I have the same velocity over time?
Same.
So, describe a car that's going at that velocity. What's it doing?
Going at the same speed.
So it's going at the same speed, right? Right?
Yeah, it's just
It's constant velocity, right? It's constant velocity, isn't it? Yes? Yes? Yes or no? Okay, all right. Define, how about this? How about if I have a car going like this? Are you ready? What's happening to that car? It's doing what? It's going faster and faster. What? Now you know enough. Would it surprise you that you already know a lot of physics? If you get into a car and you press the gas pedal and you hold it down, what's the car going to do?
It's gonna accelerate.
And what's it going to do?
Speed up.
It's going to speed up. And what physics word describes speeding up? Starts with an A. Yeah, accelerates. That's a physics word. Did you know that? That's a physics word.
It is.
Yeah, it's a vector. It's a physics word. Acceleration is a vector. What does that mean? But you know what it means. Jamie, you stopped at a red. Your parents are driving. I hope you're not driving, are you? Oh, okay. I don't know. Some kids, I don't know. Terrible, right? They press the gas pedal. They're stopped at a red light. What do they do? They want to start. They want to go 90 kilometers per hour. What do they have to do? They have to press the gas pedal, right? And then they'll accelerate. Do you know what the word acceleration means? Speeding up. This is accelerate. This is accelerate. You ready? Don't you have to speed up to go at a higher speed? I'm stopped at 0. I want to go, "Arrgh!" Then I can go at a constant velocity, right? Yes? But doesn't accelerate mean to speed up? Doesn't it? So isn't this accelerating? Isn't that accelerating?
Yes.
Right? What does this mean? So I accelerate. Okay? What's that mean?
You accelerate and then you stay at the same.
I accelerate and then I stay at the same speed, right? Same velocity, right?
Yeah.
How about this?
You decrease.
What's that? What's when you decrease your speed? What's that called?
Slow down.
Slow down. Excellent.
Steeper.
What's a good way of saying that physically? Starts with a D.
Decrease.
Who said that? Very good. Decelerate. You know physics? You've taken it before?
I wish I could.
When you were younger?
Yeah.
I mean, you can't be much younger than you are now. I mean, you are only 12, right?
Yeah.
Yeah, okay.
13.
13. Whoa! Old woman. Okay, vieja. Are you the oldest? You have gray hairs yet? Okay, excellent. Okay. All right, we just simply call Vivian vieja, which is Spanish for old woman. Okay, vieja! Okay. All right, she has gray hairs. We call her the gray old woman. Okay, now. So that's going to be decelerating, right? So you're going to accelerate, same speed, you're going to decelerate. Easy stuff, isn't it?
Yes.
It's interpreting graphs. Pretty easy, right? So that's what I have here. So let me ask you what this means. Okay, we have, do you see that I have 1, 2, 3, 4, 5 different segments? Do you see I have 5 segments? I have A, B, C, oops, C, D, E. Do you see that? Alyssa, I saw that yawn. This is the best I can do, and I'm boring you? Couldn't be that it's the last period of the last day of the week and it's been a long week. That's probably it. I'll give you the benefit of the doubt, Alyssa. Okay. Julie, how you doing over there, all right? You're leaving? You're fed up. You're going to get your water bottle. Excellent. 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 Okay. So what's happening during line segment A? What's happening?
The velocity. The acceleration.
Accelerate. It's accelerating, right? Would you say that's true, Laura? Jamie, what do you think? Do you see that? As my time is increasing, my velocity is increasing. Is that acceleration?
Yes.
Yeah. Jamie, what do you think's happening during segment B? Same speed. I like that. Right now, I am allowing you to use speed and velocity as the same word. Is that okay?
Yeah.
We'll change it later, but right now, you're fine. Okay? I do that a lot, don't I? Excellent. Okay, excellent. Now, what's happening during line segment C?
The acceleration.
Nora, acceleration. Excellent. Iman, what's happening during line segment D? I'm going like this. Accelerating, going the same speed, or decelerating? It's accelerating. So in other words, I'm increasing the velocity. Am I increasing the velocity? No, what am I doing? Luke, what's happening during line segment D?
Same speed.
Same speed, correct. Excellent. And line segment E, Sierra,
You're decelerating.
I'm decelerating. Okay, you all right with that?
Yes.
Are you okay? Are you sure?
Yes.
Now, let me ask you, we're almost done. Give me another 15 minutes tops. Tops. Okay? I do that awful lot. Tops. Okay. I know that velocity equals distance over time. Meters per second. Okay, we don't do weird things on the chairs, right? Excellent, class. All right. Do you understand that that's true? Do you accept that?
Yes.
That velocity equals distance over time. I drive to Dubai. I'm really short. I drive to Dubai, and it's going to be 120 kilometers to Dubai, and it takes me an hour. Right? How fast was I driving? What was my average velocity? What was my velocity? If it was 120 kilometers and I did it in 1 hour. What is it? No. What's my velocity? Well, if my distance is 120 kilometers and my time is 1 hour, what would my velocity hit be? Yes? 120 kilometers over 1 hour would be 120 kilometers per hour. Would you agree with that? Yes or no? Julie, are you with me? Are you sure? That's not what Nora told me. Yeah, what a great look that was, man. Whoa! Stop traffic. Excellent. What a great stare. Awesome stare. Okay, so, now. All right, so. If velocity equals distance over time, do you know what distance equals? No? Maybe?
Distance equals. Yes, no, maybe so.
What is it?
Velocity divided by time.
Well, I know. I'm not asking you to do algebra. I just thought some of you may have known because some of you have pre-algebra, correct? So how many people have pre-algebra? Raise your hand. How many people have algebra? Raise your hand.
We have algebra courses.
Yeah.
So distance equals velocity times time. Okay? So if I found the area here, what's the area of a triangle?
Base times height times.
Area of a triangle, right? Equals 1/2 the base times the height, correct? Yes? What's the area of a square?
Length times width.
Length times width, okay? So if I multiply, what's this? What's the base? 5, right? What's the height?
15.
50. Is that a triangle?
No.
Is it a triangle? That's not a triangle?
Triangle.
Whoa!
I just saw the square.
Yes, exactly. So what would the area be of that? What would the area be? I need the number.
Base times.
1.5.
1.5?
1.1.
So 5 times 50, 1/2 of 5 times 50 would be what?
125.
125. Okay, can I erase this? Okay. So, we're going to number these segments. We're going to call that segment 1. Okay? And we're going to shade this. That's segment 1. Okay? And that's going to be area. Okay, we're going to say segment. And we're going to say area. Okay? So we're going to say segment 1. What's the area? 5, 1/2 of 5 times 50. 5 times 50 is 250. Half of 250 is 125. Okay? All right, you got that? Let's do the next one. Let's do 2. So, what is 5? 5 to 10 is what?
15.
No.
Five.
This distance, the distance between 5 and 10 is what? 5. This height is 50, right? So what is 5 times 50? What is 5 times 50? 250. Yes or no?
Yes.
Are you supposed to have a calculator?
Yes.
Are you sure?
Yes.
Okay. So 5, so number 2 is going to be 250. Yes or no?
Yes.
How did I get that?
You multiply.
This is segment, we'll call this formula. This is 1/2 the base times the height. This is length times width. Okay? Yes?
Yes.
Okay. So now we have established that this, okay? All right? So now let's do the next one. Now, is there a problem with this? What's the problem? What's the problem?
This one.
What do I have to break this down to? A triangle and a rectangle. Do you see that?
Yes.
I put one there that you purposely had to manipulate. So this one is going to be broken down into 2. Okay? We'll call them 3A and 3B. Is that okay?
Yes.
Okay. You ready? What is going to be 3A? What's 3A going to be? First of all, is it a triangle or a rectangle?
Triangle.
It's a triangle, correct? So what's the area for a triangle?
Half times
1/2 the base times
height.
the height. Okay, good. 1/2 the base times the height. Okay. So, what is 1/2? So it goes from 10 to 13, which is what?
3.
Which is
3.
3. It goes from 50 to 60. So it goes from, so this is 3, this is 10. What's 3 times 10? 30. What's 1/2?
15.
15. So do you see that this is going to be 15?
Yes.
Yes or no?
Yes.
Are you sure?
Yes.
You're positive?
Yes.
Excellent. All right. What about 3B? What about this? You do that right now. Tell me if you can figure it out. Nora, did you get it? What'd you get? 150. 5 points for the team from Norway. Excellent. I like that, Nora. Excellent. Excellent. Very good. 10 to 13 is 3. 0 to 50 is 50. 3 times 50 is? Excellent. Are you good at math? Pretty good? You're not good at math and you can figure that out? Excellent. Because you have to interpret a graph to get the numbers. Okay? So, it's going to be, is it a rectangle or a triangle?
It's a rectangle.
It's a rectangle. So is it going to be 1/2 the base times the height, or is it going to be length times width?
Length times width.
Excellent. So it's going to be length times width is going to be 3B. And what is the answer going to be? 450?
150.
150. Excellent. All right? Good. Now we did that, right? Let's do this one. We'll call this 4. Okay? So what is 4 going to be? What is 4 going to be? I'm not going to tell you. You should be able to tell me now. Jamie. You can do it.
240.
What is it?
240.
220?
40.
240?
240.
Excellent. The team from Australia is on the board. That is superb. Excellent, Jamie. Very exciting. So, Jamie, is that a rectangle or a triangle? It's a rectangle. Are you sure? I love it. You're tough to fool. Like it. Yeah! Length times width. This is 4. And you're saying it's 240.
Yeah.
Excellent. Because it's 4 times 60. Excellent. Yes? So now we can color that in. Okay, now, here's the one. We're going to call this, what are we going to call this, do you think?
Number 5.
5. Okay, good. Now, number 5. Excellent. 17 to 20, 0 to 60. Oh my God, look at all those hands. Alyssa, yes! What do you got, girl? 90. Excellent. Is that correct?
Yes.
Is it correct? Are you sure?
Yes, I'm positive.
We are
She's right. You're awesome. We deserve-
excellent. Excellent, Melissa. Very well done. Very well done. Excellent. So that's 90. Why? 3 times 60 is 180 and 1/2 of that. 90, right? We're on the board, baby. Yes.
We deserve a cookie.
Okay. God bless Alyssa. United States? USA is on the board. Like it. So this is going to be 1/2 the base times the height. This is 5, and this is 90. All right, now, this is really hard. This next part is hard, okay? You ready? Can you add this? Do it. What do we got? I need everybody to do it because I need some verifications.
Just do it on my iPhone.
It's going to be 125, 250. Shema, you did it already? 870. Let's see if we have some verifications.
870. It's 870.
Do we got verifications? What do we got? Julie, what do you got?
870. Do we deserve a cookie because we're doing so well?
You do. You can have a mental cookie. You can have a mental cookie.
I want a mental cookie.
Okay, here, catch the mental cookie. Excellent. It was baked by my mother. Okay.
I got
870. Excellent. So the answer is.
How'd you do that?
All right, now, didn't we do velocity times time, 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 yin, 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 didn't we?
Yeah.
So what are these values? They're going to be what? Aren't they going to be distances traveled? Remember? Distance equals velocity times time. Now, what are the unit labels for distance? What are the unit labels in physics for distance? Let me ask that again. What are the unit labels for distance in physics? What are the unit labels for distance in physics? On the count of 3, I want you to shout 1, 2, 3.
Meters.
M for meters. Excellent. So, here I am. I took a trip. I accelerated. I went the same speed. I accelerated. I went the same speed. Then I decelerated and arrived. Okay? Yes?
Yeah.
And this area, the area under the curve, the area under the curve is total distance traveled. Total distance traveled. Okay? Shall we do one more really simple one and then I'm done? Is that okay? We're going to do a very simple one. You're going to say, Mr. Darcy, you're going to get a reputation of actually being nice. This is so simple, but don't tell anybody I gave you a simple one, okay?
Yes.
All right, you ready? Okay. So let's see, can I erase this? It's kind of pretty looking, isn't it? You kind of don't want to erase it. Yeah? Okay.
Just change the whiteboard.
Oh, I could do that. What a great idea. I have other whiteboards.
I know, I'm so smart.
What a great,
I am so smart.
what a great idea.
But how can you do that?
What a great idea. Okay, so let's see what part of the whiteboard is on. Okay, so this is about right here.
Yeah.
Is that on the board?
Yes. Yeah, it's on the board, but you can go higher.
I can go higher? All right, well, that's about all I can reach, so that's okay then. All right, so let's do an easy one. You ready? Are you ready? Now you're going to find the distance traveled. Are you ready? Are you sure?
Yes.
Okay. Velocity, meters per second. Time, seconds. We're going to say this. This is going to be 10. This is going to be 70. Right? What is the total distance traveled? In other words, what's the area under the entire curve? What is it? Can you do this? I want you to do this by yourself. Oh my God, Alyssa is the first one with her hand up. 10 extra points. Remind me. 350. Excellent. You guys, I'm telling you, Alyssa is overtaking the entire group.
She's on the
Okay? She's on a roll, baby. She's on a roll. It's going to be 350 meters. Why? It's going to be a triangle, right? The area of a triangle equals 1/2 the base times the height. It's going to be 1/2 10. The height is 70. 1/2 of 700 is 350 meters. And I am done, man. I am done. Done. Are we done? Are we off?
Yep.
Are we off?
Yes.
I remember when you do that.
Okay. Have a good one. Hey! Have a great weekend and be careful out there. But we have some practice to do. We're going to spend the rest of the time practicing.
Thank you.
Okay? All right.